big difference with Vortex is that we're going to add the gaseous aspect into the system, so that we're also covering the volume of the room that we're protecting. So Vortex will be an extinguishing system rather than a controlling system. The second technology that we're going to use is going to be an inner gas, or just your clean agent, the gas system, where the concept is that we're going to add this into the room to lower the oxygen concentration down to a level where it is okay for people to remain in, but it is not okay for a fire. So a fire will be extinguished at around 16%. We will go down below that level, and it will be 12.5% of oxygen at the end of the discharge. The big thing for an FM200 or a NOVAC or any sort of gaseous system is that you need to have a sealed room. You need to make sure that your complete room is sealed so that the gas doesn't escape somewhere. And to do this, you need to have a construction cost, and also because you're sealing the room, then you need to have construction cost of having pressure relief dampers to assure that you're not damaging any equipment or potential people inside can still leave that area. So the good thing about Vortex is that we can allow permanent openings to be there without losing the effectiveness of the system. So the room integrity does not need to be completely sealed. That's the biggest advantage that we bring to the table with the Vortex system when we're comparing against the gaseous system. Now, when you're looking at the green solution, then Vortex is your ideal fit. Why other alternatives will have chemicals? Maybe some of you have noticed that 3M has announced that they're going to discontinue the NOVAC 1230 due to the PFAS issues that they have in their manufacturing. Also, FM200 is being phased out in Europe, and the Middle East will probably soon follow as well due to environmental reasons. Because we're using pure nitrogen and water, we're using natural resources. So we're not having any sort of global warming effect, ozone depletion, and that doesn't only mean that that has an effect before you have a fire, but also during and after, because you're not going to have any byproducts that can damage the equipment that is inside of your room, inside of your area. So a little summary, what exactly do we do with the Vortex system? We're going to combine those two technologies together. So that's being hybrid. The biggest advantage against the gas is that we do not require full integrity. And the biggest advantage against water mist is that we're going to completely put out the fire. And in addition to that, the amount of pressure that we need on the water tank is going to be regulated from your nitrogen pressure. This means that you completely eliminate the pump, so you don't need to have maintenance on the pump, you don't need to pay for the energy that a pump costs, and you don't need to have a redundant pump as well. So an additional thing there, because you might hear me say 200 bar and thinking, that's high pressure, we like high pressure. The working pressure of the system is only 1.7 bar. So at the nozzle, we're reducing the pressure to 1.7 bar. That is going to happen in our panels. More on that later, how exactly that happens. But basically, we're going to reduce the pressure of 200 bar in the cylinder to the working pressure of 1.7 and keep that at a constant level. When you're looking at a fire triangle, the most basic form of representing a fire, it needs all three legs to continue. You have the fire itself, and that's not something that you can remove. So what you can attack, however, is the temperature and the oxygen in the room. The temperature we're attacking by adding that very small droplet of water mist. And when I'm saying small droplet, it is going to be 7 times smaller than your average high pressure water mist system. The average droplet size is around 10 micrometer in size. So when you're looking at water mist, it's going to be roughly ranging from 60 maybe to 200 if it's low pressure. But that's the biggest advantage, that we're going to be very efficient into covering the heat of the fire and taking the heat away from the fire. Now when we're talking about the gas, that is going to attack the oxygen in the room, lowering it down so that the room can still be occupied, but that the fire will be extinguished. Now talking about it is one thing, it is probably easier to show a video, and that's why we have the sound that I needed to give you some idea how does it sound. This is an actual commissioning that we did for an American client, where it was a steel mill factory, and they wanted to see, okay, we have 24/7 permanency in this room. There's always going to be somebody here. Will this hurt my people? Will this hurt the workers that will be here? And the first thing that we said, okay, fine, we'll be in there with you and show how the system works. In addition to that, we don't always only have people there. There's working and live equipment. So there's a server room in the middle of that room, and there's also control equipment at the side. That is live. So this means that you can have the system working on operating equipment. The big thing about this video though is when the person holding the camera is walking outside of the door. So here you can see that the door has been completely open during the discharge. You can also see that the mist is remaining inside of the room. The name of the system, Victaulic Vortex, is the reason why it is remaining inside of the room. The nozzles are going to create a vortex effect, which is known in physics as sort of a whirlwind, and that is going to ignore permanent openings and going to have a suction effect that will be keeping the mist inside of the room. As you can see, the people inside are safe, and well, you also saw the guy trying to light the fire. He was not able to, that's not really the largest fire. But the thing about that is that you're going to have protection at the top, at the bottom, in a carpet cabinet. It doesn't matter where your fire starts, it will be extinguished by the vortex system. How do we do this? How does it operate? We have different type of emitters. We call them emitters, you can call them nozzles. It is just a Victaulic thing to call them emitters because they're emitting the hybrid medium. And we have different sizes, which is going to vary. Simply explained, if you have a data center and you have the false floor of the data center, you won't need the same amount of volume of nitrogen below the floor as in the main room. So by choosing a different type of emitter, a different nozzle size, you're not going to add the same amount of nitrogen in the water. The materials that we're using is going to be brass, stainless steel, or PVDF. PVDF can be in very, very corrosive environments, like that steel mill, that's where we have used it. But normally we're going to have a brass version, which I have over here. It has an orange cap on it. In the sprinkler industry, this is something that is thrown away immediately when it comes to site. We keep them all for the vortex system because they're dust protection. They're open nozzles, they're a deluxe type of system. And because of this, we keep them on in any application, so there's not dust coming inside of the pipe. So when you have a discharge, that the first thing that is coming out is not a lot of dust that was going into the pipe over years. How exactly does it work? For those who have noticed it, yeah, you can take the cap off. You have two openings for all of for these emitters, and the one at the top is going to be for your nitrogen. The one at the side is for your water. Both are going to be low pressure. The 1.7 I already mentioned, and the water pressure is only 5 at the nozzle itself. It's going to be larger at the water tank, roughly around 7 to 8 bar, but due to pressure losses in the pipe, it will eventually go to that lower pressure. Now the most important thing that you can see is the section view of the emitter itself. The diameter of the emitter is going to go down. Now, I believe that most of us here are engineers, and we will know this as the Venturi effect. Since the diameter is going to go down, any sort of media that you're going to push through is going to speed up at the last moment. So because it is speeding up, and that it's hitting that tip of the emitter, you're going to have a change in velocity. That change of velocity is going to create a shock wave, and it is through that shock wave that we're going to enter the water droplets. As you can see at the video, it might be a little bit small, but the water is coming out of the openings fairly usually, just like it would come out of a water mist system. Now then we drive it through that disc, which is shown here. So here this is an emitter operating, and the disc is shown, and the disc is shown here. That's where the water is going to go through, and then in addition to that you also have zones of higher pressure on the tip of the emitter. It is because of those two zones of higher pressure that the water will be atomized to a very small droplet size. And the droplet sizes that I mentioned is going to be later. First, what I want to explain is how does that vortex effect work? As you can see here, the arrows, the green and blue arrows, are indicating that the air will be pushed away when there is a discharge. When you do this under the nozzle and around the nozzle, you will have under pressure. So when you're pushing the air away, it will suck it back in at every nozzle. And that is that vortex effect that I'm talking about. This will happen concentrically around that emitter. So that is why an open door can be ignored. Now, to be honest, we're not saying please open all doors and windows because there's a fire going on and it's vortex. No, we're more talking about permanent openings like cable ducts, electrical work. If you drill a hole through a wall, then you have permanent opening. There's a lot of gas systems currently today that are being installed, but they're not really maintained properly. So normally, according to the standards, you would need to do a door fan test on a yearly basis to check, am I still in range? Is my system still going to work? And the fire contractor can come in, they do a door fan test, they say, okay, first time never works, so probably, okay, we have some leaks. That needs to be sealed. Okay, it's sealed, we do a second door fan test, fine, we're in range. And they leave, they say we're done. And then the next week another contractor comes in, and they don't know fire code. They drill a hole in the wall, they don't do a door fan test, and they move on. And that can be a permanent opening that has an inefficient gas system. And that's something that the vortex system gives some safety. Even though you have those permanent openings, we don't mind. Again, I'm not saying remove a wall and it's going to work. You still need some enclosure, but there's a limit to how much opening you can have. All right. Again, on the water droplet size, this is shown here. What are we looking at here? This is the x-axis is showing the droplet size, and in the y-axis is the amount of droplets that are being created with the system. The blue bars are indicating the vortex. So you see that they're around that 10 micrometer mark. And then as a comparison, we have added the high pressure water mist, which is indicated in brown orange. And you can see with the water mist that you're going to have a longer draft, and also the amount of droplets are going to be lower. This means that water mist needs to add much more water compared to vortex. And it all has to do with the relative surface area of heat exposure. What does that mean exactly? The easiest way I can explain it is if you have an oil fryer. You fried something, you have the oil, and suddenly that catches fire. Now what are you going to do, or what are we all being taught? We're not going to spray water on top of it, because oil and water, not the best of friends. So what you're going to do is you're going to take a damp cloth and surround the fire, cover it completely, making sure that the heat is being transferred that way. This is similar how a vortex system works. Because we're using a small volume of water and we're making it into a very fine mist, we're going to cover the fire from all sides, taking heat away much more efficiently compared to a sprinkler system, compared to a water mist system. Now, usually I do the comparison or a quick calculation in the hall that I'm standing in. Now, currently we're in a very large convention hall, so to estimate how big this is going to be hard. So I'm going to use just the volume of 150 cubic meter as a sort of an example, which is your standard server room or a relatively small server room. That would then need to have 3 nozzles in total. That would run for 3 minutes as well, and 1 liter per minute per nozzle. So we're talking about 9 liters of water, or maybe a bucket of water, to protect the 150 cubic meter server room or electrical room. All right. Here it will be a little bit more, but still, if you compare it to water mist, it will be peanuts. All right. Okay. The second thing that I wanted to talk about is why do we choose nitrogen? Not only for environmental reasons, but also it has to do with the room integrity of the system. This was a graph that was shown at the NFPA conference in 2001, and our research and development team that invented Vortex was there. And they had a look at this graph and thought, okay, that's strange, why is nobody using nitrogen for the fire protection? Because what we're seeing here is that the NFPA did testing on different gases. You can see that it's a cold slide because the first gas that is used there is halon. Halon is not being used anymore globally due to environmental reasons. But there's also hydrogen there, there's FM200 there, CO2, just a comparison of different gases. I believe that Novak at that time was not really invented yet, or not really in the market just yet, but you can compare it similar to FM200 when it comes to the graph side. What exactly are we looking at? X-axis is the amount of openings, so basically the NFPA did testing in a small volume, 16%. 60% of oxygen. And then they timed that time. How long does it take? How long is the gas remaining inside? Normally for a gas system, you need to have a standard time of 10 minutes retention time. And here you can see how important it is to close off your room completely. The first one, maybe it is a little bit small, but the lowest one, here, that's the FM 200 one. And you can see with the slightest amount of opening, it immediately drops the retention time. And that is why it is so important to completely close off your room to have a sealed environment. Now, the one that's standing out is nitrogen. Nitrogen is over here, and the reason why it stands out makes sense. Why? What are we breathing currently? The air that we're breathing currently is about 80% of nitrogen. So if you're adding nitrogen here to bring the oxygen level down, the concentration difference between the nitrogen here and outside environment will not be very high. If you, however, we currently are breathing CO2. Luckily for us humans, it's only parts per million. But if you're doing a CO2 discharge here, not only is it going to be heavier, so it goes to the bottom, but also because the concentration of CO2 in the normal air is not very high, once it sees an opening, it's gone. It tries to balance itself out as quickly as possible. The same with FM200. And you can see as well, the better gases are going to be your inert gases. Energen is one, argonite is one, and then any sort of combination of inert gases will score better. But there's only one that scores best, and that's nitrogen. So in addition to that vortex effect that we're creating, we're also having the effect of nitrogen not trying to escape, so the retention time is going to be higher. This means that for a fire brigade, for example, this can be very important. Because what they don't want is that the fire is out, they open the door, and it suddenly reignites, and they have to start looking at where is the fire exactly starting. So on that aspect, vortex has a big effect. On other aspects, that's more on the construction side. As I said earlier, normally with a gas, you really need to seal your room completely, and that means that you then need to add pressure relief dampers. That means that you need to maintain that. That's all something that you don't have to worry about with vortex. Again, I'm not saying it's 100%, but still, it's over a long period of time, you're safer with the vortex system. When we're talking about life safety, the NFPA standard is stating that we're going to design between 12.5 and 16% of oxygen at the end of the discharge, meaning that you can have occupied spaces. This doesn't mean please stay in the room, play some cards with your colleagues before you leave. There's still a fire going on. And smoke of the fire can harm you more than the system or the system itself. The point is that if you have a discharge and you are physically not capable of leaving the area, or the fire is between you and your exit, the system will not harm you. So that's according to the standard. You can also be below 12%, but then you need to evacuate quicker. You need to be out of that room in a quicker time. That is similar to a gas system. Yes?
Normally, vortex is operating how can you make sure 100% is the problem the whole room during fire?
So we would calculate how many nozzles that you would need to fill that volume within 3 minutes of time. So the most important thing is going to be the amount of nitrogen. The amount of nitrogen is going to decide where are we going to be and the oxygen level at the end of the discharge. And then the additional thing will be where do we place our nozzles? And the nozzles are going to have that effect. So when you're placing your nozzles as an engineering aspect.
So there will be a lot of vortex inside the room.
Yes, correct. It's
the whole room.
Yeah, it's not only one nozzle, but you would have a deluge type deal where multiple nozzles will have that vortex effect happening.
Thank you.
No worries. An important one when it came to standards and approvals of the system, what Victaulic did is what we do for most of our products is we contacted FM Global. We are still an American company, so that's the first point of contact that we had. And there we said, okay, we have this new technology, we have this new system, how can we commercially bring it into the market? It is using two existing technologies, water mist and clean agent, but it is the combination of the two. And FM said, okay, fine, let's start testing against the water mist standard. And they did all the testing, we were successful, and that's how we got the approval in 2008. However, because we were considered then, in their eyes, a water mist standard, they didn't add really the gas, or they didn't really think about the gas that was added. What do I mean with that? They basically took their standard for water mist, which was this FM 5560. They did a control F search for every time water mist was mentioned, and then they did a control or replace all with water mist, changing into hybrid water mist. So the standard that we had was basically the water mist standard. The issue there is it didn't mention gas, it didn't mention room integrity. So for us that was a little bit of a downfall because the biggest advantage that we had, we couldn't really prove to anybody. Then we did testing with UL, we did testing for clean agent standard. We were also successful, but the same issue. There's no mention of water in our standard, so it cannot be used according to the standard. So, because we were in a gray area, Victaulic said, all right, we're going to start from the start and we're going to contact NFPA. We worked together with the NFPA to create a complete new standard. So, currently it was published 3 years ago, and we are very proud to say that Victaulic was a committee member. FM, UL, and multiple contractors and also insurance agencies were part of that committee. And now there is a hybrid standard. What does a hybrid standard mean? It is inert gas and water, and a very important part there. Can somebody check, or can somebody tell me what is the most important sentence or word in that standard name? Hybrid is a nice one, yep. But it is a different one that I'm looking for. Extinguishing. So the most important part of the system is that it's not going to control your fire like a water mist will do or a sprinkler system will do. It's going to put it out. That is how we were tested. We were tested with no matter where I put a fire here, the hybrid system is going to put it out. So that is a very important part or point if you're looking at this sort of protection. So where do we approach this? Where do we look to which sort of applications? It's going to be critical, crucial applications where the business continuity can cost a lot of money to the end owners if they have a downfall. So any sort of control rooms, electrical rooms, substations, cable trays, transformer rooms, generators, turbines, I can keep going on. Even museums is an option where we have installed Vortex over the years. So we have a lot of references in different type of applications, but the main point always is whatever in that room is going to be very expensive for the client. So you already can hear me saying that it's going to be a little bit more expensive than a sprinkler system. It's a different level as well. But the point is that we're protecting the important equipment inside of the area.
Excuse me?
Yes.
What kind of pipe material we are going to use in this system?
Sorry, can you repeat the water quality?
What kind of pipe materials?
Okay.
Is it same carbon steel or whether we have to use other materials?
So there's a couple of pipings that you have, because first of all, you're, can I come back to that question, please? Later I'm going to have a schematic which is going to show all the pipe work and all the layouts. So then I can point out this is going to be this, because you have a high pressure part, you have a low pressure part, and you have obviously two lines with nitrogen and water. So there's three sorts of piping that we'll need to look at. I'll explain it later. Yeah.
Okay.
Excuse me. You mentioned that you have approval for FM 5580
Yes.
for the machine area and turbine.
Yeah.
As a water mist, I know it is application by application.
Yeah, correct.
Do you have for how many applications to be using your Vortex water mist?
Very good question. And one that I didn't address yet. So at the beginning of this year, we did fire testing with FM, because the big thing for them was you don't have a standard to compare yourselves to, so we don't know how we're going to test you as a hybrid system. At the beginning of the year, we did fire testing with FM, those were successful, and now we are working with FM to have a data processing equipment approval. Data processing equipment, meaning that any sort of room that has critical electrical applications, those are going to be covered with this new approval. We're waiting now for FM to give us the stamp, and once that happens, we're going to do a big launch online on social media and in all the different areas in the EMEA and also in the US, to promote the approval of the system. So a very good question.
What about also the application of low voltage rooms?
Which type of rooms?
Low voltage rooms.
Low voltage rooms will be covered.
Electric
Yeah.
hazard that way.
Yeah, those rooms will be covered by data processing equipment. So control rooms, low voltage rooms, medium voltage rooms are all going to be covered by that scope that FM has. They have a list of applications that are falling under that approval.
Do you have approval for protecting tunnels?
Tunnels is a challenge. Tunnels is a challenge just because you're using gas and there's going to be two openings and there's going to be ventilation, so we don't have an approval for it. We have done projects though where we have project-specific approvals, but not an FM or no. It's going to be the client then and the local insurer that approves it on the local level.
I'm sorry, I have several questions, but be patient with me. What is your approval for the nozzle height?
The nozzle height that we tested with FM is 7.5 meters.
How many?
7.5.
7.5.
Yeah.
With which factor? K factor?
Well, it is not with a K factor since it is not a sprinkler system. It's rather going to be a hybrid factor, which is explained in our training. So if I say it now, if I say 0.307, that's not going to make sense to you. So it's not a factor like you have in a sprinkler system.
But we have to use it to decide water size, water demand.
Yes, correct. But the amount of water is going to be decided on the application and the volume, not on, it's not something similar like a K factor. It's not the same design as a sprinkler system.
Okay, thank you.
The normal ventilation that you have running can be just, well, let me just start with if the fire starts, any sort of external ventilation would need to be shut down. Similar to a gas, you don't want to add any oxygen during the discharge, and also if you have any extraction ductwork, those need to be closed off. However, when you're talking about extraction of the gas, it's nitrogen and it's water. Nitrogen is already in the air here. If you open the door, that's what I do in the demos in Belgium. If you open the door, it's just going to compensate and equalize. You don't have to do anything or install extraction.
Yeah, thank you.
No problem. There was another question.
Two questions, please. First of all, there is another brand have a system. They don't mean hybrid. They said it's mist system, but using nitrogen, not using
Twin fluids type of system.
Like aquamist or whatever. We have it. What's the difference between they using the nitrogen in their system and Vortex also using the nitrogen? This first issue. Second issue, for the cable tray or tunnels, the water mist is already approved as an application. Okay. There is ventilation, there is everything you say. But I think there is a problem in the continuity of the pressure in the pipes because the water mist stays on the pumps, so they can give continuous pressure. The problem is for Vortex to use the system inside the tunnels, especially for some tunnels 1 kilometers, 2 kilometers. The problem is to use this to maintain the pressure inside the system, or there is another reason.
We maintain it in, I'm going to say the same answer. In a couple of slides I have a schematic how the system works, and then I'm going to say how the pressure in the outgoing pressure is maintained at the same level, no matter how far it is. So there I'll explain it and I'll answer that question back. When you're talking about the competition that is currently there, so you mentioned Aquasonic, okay? There's Aquasonic, there's also Synorix from Siemens, which is more European. Both of them, like you say, are more considered like a water mist system. The water droplets that they have are going to be larger than the 10 micron that the Vortex system has, so there's already the big difference. And in general, we see that like a Tyco, Johnson Controls, or a Siemens are not really focused as much on their hybrid part, but more on their low pressure water mist. How does it change, for example, from a Mario system? A Mario system sometimes also uses nitrogen, but they're using it as a propellant to push their water. So their cylinders are just a replacement of a pump. The amount of cylinders that they have will never be enough to bring the oxygen level down. So they're just using it to bring the water to the nozzles. So that would be different. That's why they are considered like a twin fluid system in the LFP 750, which is different than hybrid. Right. Yeah. And on your question about pressure, give me 2 slides. Research that we have done over the years. So, like I said, 2003 we started with the idea. We had multiple tests done with FM Global, and we did it in different volumes. The largest volume that we did the testing in was 3,600 cubic meter, which had a height of 7.5 meters. To come back to your question, this is how FM works. They do a test up to a certain volume, and that is your limitation of the system. Now, can anybody tell me, I asked the question yesterday in Amman as well, what is the limitation of a Novak system?
9 meter. 9 meter.
Well, volume-wise.
Volume wise.
Energen system.
4.2
Volume wise.
maximum value.
Maximum volume.
The volume, maximum volume that a Novak system can protect. Does it have a limit? We can do that too.
Yeah, big spaces we are dividing into zones.
Yeah, so that you're within the approval range, then you increase it based on the results. Yeah. That's a way to go around the approval. So that's something similar with the, what I'm aiming at is that the FM approval that we have is limited to 300 cubic meters. 300 cubic meters is not that high or that large, but the thing is that that was the room that we did testing in with FM. Does it mean that it will not work with 600 meters or 600 cubic meters? Not precisely, but you just can add another zone, you can see it then. All right? So that's why I'm showing here. This is how an insurer will work. They will test only up to a certain volume, up to certain conditions, and that's, now we know it works in these conditions. If you have different conditions, you either need to do another test, or you need to work locally to have an approval. What we did originally in the system is work from 130 cubic meters up to 3,600 cubic meters, and we saw, obviously, the bigger the volume, the more nitrogen and water that you need. And this was linear. So even though FM says you cannot extrapolate over that amount, you can work locally to have multiple zones and work within the scope of the you have a question?
I had a question on the HVAC and extraction ratings.
Yeah.
Why?
Yeah.
I know that you probably will cover how it works, but no downput closure is required.
If it is fresh oxygen, you would still need to close that off because you don't want to have oxygen running into the room. If it is internal, then you don't have to worry about it because the vortex is just going to go internally as well.
Really is appreciated.
Yes. Yeah. Other research that we have done next to FM, some of you might know that the inner gases had an issue. This was in 2008, for example, in a Scottish server room or a data center, where because the fire protection system discharged, the complete server room broke down. It was completely destroyed. It was a governmental building, and they thought, okay, why was this? What happened exactly? And they did some research, and they found out that the frequency and the pressure of, it was an Energen system, the frequency and pressure of that system, when it discharged, it had the same frequency of the hard disk drives that were installed in that data hall. Because of this, they went into resonance, and they completely broke down. So in order to make sure that the Vortex system did not have the same issues, we did multiple tests on different hard disk drives, and we put them all into a server room. We did a reading-writing test, looking at the performance during and without the Vortex system operating. We have it all written down in a white paper. If you want, you can certainly share that. It's also online for free on the Victaulic website. And we made this video here. We had several screens there, and funnily enough, we're still using that equipment up to this day. Not because Victaulic is not doesn't have the money to buy new equipment, but more to show we're doing a discharge like this 2 times, 3 times a week for 8 years. It's still the same equipment. If people have wonders or worried about, okay, you're using water on an electrical room, I don't like water. We agree. Water, electricity, they don't like each other as well. But because you have that tiny water droplet, it's not going to have any conductivity, it's not going to have any damage on your equipment. What you saw there was that the reading-writing test with the Vortex system operating and without had the same performance on your hard disk drives. So we did that for multiple hard disk drives to show you the effect of the Vortex. The good thing is, because we're working at a lower pressure, the 1.7 bar, that you're not going to have a blast in the room when you're doing a discharge. I'm not sure if anybody has ever been in an FM200 or an Energen discharge. It's a pretty big blast. When it needs to be there in a couple of, is it half a minute, a couple of seconds? But that's a large volume of gas that needs to enter that room very quickly. And that can have an effect of pressure on equipment. So for that reason, the Vortex is going to build up slower. The discharge time is going to be 3 minutes. And we're not going to have the same pressures as a gas system would have. Now what I haven't talked about, yes?
When you say droplet, although you are from a water vapor state,
So the size of the droplet size, the water droplets, or
yeah, the water droplets mean you are in a vapor level of the water.
a vapor level? Or
Yeah, it is gas, water gas.
What we do, or I'm not exactly sure if I understand the question, but in our discharges we add some paper, we add some napkins to show the effects of the water on that paper. You can even write something down and it will still be visible. But I'm not sure if that is exactly your question.
So it means it is a water dust.
It's a water, yes, correct. Yeah. Very, very fine mist with the gas.
And it cannot grab any electrical cables or.
Yeah, no. Another thing that was in this video as well is that you had a very old computer screen. Again, not because Victaulic doesn't know new equipment or cannot buy the new equipment. It's more that for who remembers, and I believe everybody here, I think I was the last generation that had those screens, but they had ventilation units at the back, holes at the sides, and they were constantly drawing air through them. Open wires were just connected in that screen itself. So the reason why we still have that there is because that screen is constantly drawing the air through it. If you do a vortex discharge, the nitrogen, the water is going to go through it, but it's not damaged. That's the reason why we have it there. That's why we do it for eight years without having damages. Now, this is our facility in the US. Which you are all more than welcome to visit. However, we also have facilities in Belgium, where I am from, or in Dubai, where we can show you the unit working. Because a big change, I can show you whatever presentation and whatever slide I can do. I'm still a sales guy, and if you want to believe something, then you have to see it. So if you want to come over, feel free to talk to my colleagues. I can organize it in Belgium, or we can organize it with Peter in Dubai to have an actual discharge for you or your customers, for whoever wants to see it. I'll first address the pipework, or first I'll explain how the schematic works. This is a part where I have to explain that Victaulic is a manufacturer, and maybe also a question: does anybody need to have a quick 5-minute break, or are we good on time?
Okay.
Do you want a break?
I think we're fine.
We're fine? All right, Victaulic provides. However, we work together with the training, which is needed according to the and those will be certified by Victaulic. They will be certified once they show that certification. They enter into a partnership with us. We train them completely, we keep them up to date into the latest updates of the system, but they know more than we do in the sense of detection. because again, we're not an expert in detection or fire alarm panels. Depending on the application, however, you can use any sort of detection that you want. The only thing that we need is 24-volt releasing signal. Once we have that, our solenoids will do the job, cylinders go, and we do a discharge. Now, when you're looking at this schematic here, we're protecting a single zone, and we have our nitrogen that is going to be calculated on the volume that you're protecting. Again, the more volume, the more nitrogen that you're going to provide. And in case that this has a fire, your detection will send the signal to the fire alarm panel. From the fire alarm panel, you're going to have a releasing signal going to the vortex panel, and from there you're activating the nitrogen cylinders. The nitrogen cylinders, 200 bar, are going to run first, the green line there. Here's where it's going. You can see the green line from your cylinders, 200 bar is going up until the panel. And in the panel, we're going to reduce the pressure from 200 to the working pressure of 1.7 bar. Now, your colleague is just left, but I'll repeat it maybe when he's back. The pressure transducer is a product that we're going to use to regulate the pressure, to look at the pressure at the downstream of the piping. So every emitter will need to have 1.7 bar, and that transducer will have a membrane inside. The more you push against it, the more signal is going to be returned to the panel. And that way the panel knows I have 1 bar in the beginning at my nozzles. I need to increase, so I'm going to open up my valve. You slowly open up the valve so nitrogen starts to flow to your nozzles, and then that will continue or automatically regulate. It's a little bit unfortunate that he just left, but maybe I can answer it separately. No, it's okay for me. So that will continuously measure the pressure. We'll make sure that the outgoing pressure will be 1.7 constantly. The ingoing pressure will be 200 bar at the beginning and about 1 bar at the end when all the nitrogen is gone. I haven't talked about the water yet because the water comes after the nitrogen. We don't want to have the water first because otherwise you don't have the nitrogen pressure to break down those droplets to the small size. So first nitrogen. Once we know that the nitrogen pressure is high enough, the ball valve, the green one inside of the panel, is going to open up, allowing the water to go, and then the two combine, they do the hybrid mist for the duration of the discharge, which is going to be less than 3 minutes. 3 minutes. At the end of the discharge, the pressure of nitrogen is not sufficient to break down the water, so we close the ball valve of the water first. Again, same principle. We don't want to have water dripping out of those nozzles because there can be sensitive equipment below those nozzles or emitters. And then the rest of the nitrogen will still go out. So that valve will be completely open at the end of your discharge. All right? So that's a little bit how it works. Now, yes? Yeah, correct. No, yeah, but it's going first to the panel so that the panel electrically is aware that we need to do a discharge, I need to operate my valve, and then we go to the solenoid. Yeah. Right? When it comes to pipe material, so because there is, yes.
Can I have a question? For the water line, okay, the type of the control valve to discharge the water, it's hydraulic valve, depends on the pressure of the nitrogen line or what?
It is the water valve itself, how it is operated?
Yes.
It is operated with a connection to the nitrogen line. If there's enough pressure of nitrogen, automatically it will open up.
If the pressure of nitrogen reduced, the valve will automatically close?
Yes, yeah. So it basically has a pressure switch in the nitrogen line. That pressure switch has a set point and a set point both on the upside and the downside. And once it is above or below that, it will control that valve. So that's how we control the water. Right? When it comes to the materials that we're using, we're dealing with different types of piping. Because this is high pressure piping up until the panel. That will be black seamless steel. Because it's nitrogen, you don't have to worry about water. But that will be high pressure. So schedule 160 or schedule 80 if it's 1 inch, but 1.5 inch and above, it's schedule 160. And then outside of the panel, you can see that you're having grooves. So that means that you can use our Victaulic couplings, which also means that that is low pressure. both from the water side and on the nitrogen side downstream of the panel, that will all be low pressure. The pipe material to be used there, on the nitrogen, that's going to be your standard normal pipe. They say all the pipe work after your panel will be dry at all times, and that is the reason, but the pipe work before will be under pressure up until the panel, so that's the reason why you need to have corrosion protection, and you cannot use just carbon steel to avoid that any debris is going to the nozzles. Okay?
What's the question? So, can you please go back to the, so, the FACP looks like nothing.
Yes.
I'm not very familiar